Hello gentlemen, this is Showman from Oil and Gas Field Quality Control. We have started a series of future fuel hydrogen. Today is the second video for the same subject. Last video we have discussed about the production aspects, drawbacks, advantages of using hydrogen as a fuel. Today we will be discussing what international code says about the hydrogen piping and pipelines. Let us discuss ASME code of pressure piping. Complete name is ASME B 31.2. I am discussing few points from the 2023 editions. If it is interesting for you, I will make more videos on this same hydrotest subject. Please ping me on the comment box. The one and only applicable code at this moment which is highlighted is for hydrogen pipeline is ASME B 31.12. It is applicable to piping and pipelines handling gaseous hydrogen or gaseous hydrogen mixtures to piping in liquid hydrogen service. This code is applicable up to and including the joint connecting the piping to associated pressure vessels and equipment, but not to the vessels and equipment themselves. It is applicable to the location and type of support elements, but not to the structure to which the support elements are attached. The design for pressure and temperature shall be in accordance with the requirements of Part IP for industrial piping and Part PL for pipelines. This code is presented in the following parts and appendices. A. Part GR, which is general requirements. Part GR contains requirement applicable to and referenced by other parts. It contains definitions and requirements for materials, welding, brazing, heat treating, forming, testing, inspection, examination, operation and maintenance. It also contains quality system topics common to the other parts. B. Part IP, industrial piping. Part IP includes requirements for components, design, fabrication, assembly, erection, inspection, examination and testing of piping. And the third part is Part PL, which is pipelines. Part PL sets forth requirement for components, design, installation and testing of hydrogen pipeline. There are two appendices. One is mandatory appendices from section 1 to section 9, and there is non-mandatory appendices section A to section F. Each part defines requirements for piping or pipelines as applicable within the scope. The requirements are different for different aspects of components, design, fabrication, installation, assembly, erection, inspection, examination and testing. It is required that each part be used in conjunction with the general requirements section but independent of the other parts. The joint connecting piping governed by two different parts shall be subject to exclusively to the requirements of one or two parts. It is not intended that this edition of this code be applied retroactively to existing hydrogen system. In the quest for a sustainable and decarbonized future, hydrogen is emerging a key energy carrier with tremendous potential. As the demand for hydrogen increases, the need for safe and efficient infrastructure becomes paramount. The American Society for Mechanical Engineers, which in short we call it ASME, recognized this need and developed the ASME B 31.12 code to provide guidelines for the design, construction and operation of hydrogen piping and pipeline system. The comprehensive code ensures the integrity and safety of hydrogen infrastructure while promoting the growth of the hydrogen industry. Let us discuss the key aspects of ASME 31.12 code and its significance in enabling the safe and reliable transportation of hydrogen. Overview of ASME B 31.12. ASME B 31.12 is a specific code within the broader ASME 31 series which covers various piping systems such as oil, gas and chemical pipelines. ASME B 31.12 focuses exclusively on hydrogen piping and pipeline system. Its primary purpose is to establish requirements for the design, fabrication, installation, inspection, testing and maintenance of hydrogen piping system and components. The scope and applicability encompasses both high-pressure gaseous hydrogen piping system and liquid hydrogen piping system. It applies stationary hydrogen system including production, storage, distribution and utilization facilities. Design considerations. ASME B 31.12 outlines various design considerations for hydrogen piping system. These considerations include determining the design pressure, temperature, material selection, stress analysis and safety factors. The code provides guidelines on calculating the required wall thickness, considering factors such as internal and external pressure, temperature and corrosion allowances. It also addresses design aspects related to hydrogen specific properties such as embrittlement and permeation. Material selection. Hydrogen presents unique challenges due to its properties, including its potential to cause embrittlement in certain materials. ASME B 31.12 specifies the criteria for material selection to ensure compatibility and long-term integrity. This code identifies materials suitable for hydrogen service and provides guidelines for material testing, verification and documentation. Construction and fabrication. ASME B 31.12 sets requirement for the construction and fabrication of hydrogen piping systems. It covers welding procedures, joint design and quality control and inspection techniques. The code emphasizes the need for qualified personnel, proper welding techniques and non-destructive examination methods to ensure the integrity of the system. Inspection and testing. To ensure the safety and reliability of hydrogen piping system, ASME B 31.12 defines inspection and testing requirements also. It includes guidelines for visual inspection, NDT, pressure testing and leak detection. The code emphasizes the importance of periodic inspections and maintenance to identify potential issues and ensure continued system integrity. Safety considerations. Safety is a paramount concern in the design and operation of hydrogen infrastructure. ASME 31.12 addresses safety concerns associated with hydrogen, including fire and explosion hazard, leak detection, and emergency shutdown procedures. The code promotes the use of safety devices such as pressure relief valves and hydrogen sensors to mitigate risks and protect personnel and the environment. Regulatory compliance and code enforcement. ASME B 31.12 is widely recognized and adopted by regulatory authorities, ensuring compliance with industrial standards and legal requirements. Compliance with the code is typically enforced through inspection and audits conducted by regulatory bodies. Adhering to the code not only ensures regulatory compliance but also demonstrates a commitment to safety and industrial best practices. Advantages and impact. The implementation of ASME section 31.12 has several advantages and impacts on the hydrogen industry. Firstly, it provides a standardized framework for design and construction of hydrogen infrastructure, enabling consistency and interoperability. This promotes confidence among stakeholders and facilitates the growth of hydrogen market. Secondly, this code enhances safety by incorporating industry-based practices and addressing the unique characteristics and hazards associated with hydrogen. By adhering to this code, organizations can mitigate risks, protect personnel, and ensure the integrity of the hydrogen system. Furthermore, this standard contributes to overall advancement of hydrogen technology by paramounting research, development and innovation. This code provides a foundation for collaboration among the industry professionals, researchers and regulators, facilitating sharing of knowledge and continuous improvement. In conclusion, we can say ASME B 31.12 plays a crucial role in shaping the future of hydrogen infrastructure by providing guidelines for the design, construction, and operation of hydrogen piping and pipeline systems. The code ensures the safety, integrity, and reliability of these systems. Adherence to ASME B 31.12 not only enables the compliance with regulatory requirements, but also fosters confidence, promotes interoperability, and accelerates growth of the hydrogen industry. As the demand of hydrogen continues to rise, the importance of standards such as ASME B 31.12 cannot be overstated in establishing a robust and sustainable hydrogen infrastructure. So this was just an overview of this ASME standard. At this moment it is getting popular because increase of hydrogen, and it is being adopted from different vital players of oil and gas industry of different countries, because it can eliminate the pollution risk. It will be a cheaper fuel source if the difficult aspects of this hydrogen transportation and storage can be overcome in future. The world biggest oil and gas company, Saudi Aramco, also started thinking and started doing research and development works on this hydrogen pipeline and piping technology. So hope we can see hydrogen as one of the vital future fuel. If you need a detailed video for this ASME B 31.12, just ping me in the comment box. I will try to prepare step by step about the contents of ASME B 31.12. That's all for today, my friends. If you like the way of my teaching or the topics I am discussing in this channel, please subscribe my channel, inspire me with clicking the like button, share it to your friend. Signing off for today, Showman.